Okay, continuing on with Newton's laws of motion. All that we got from this concept of inertia that we learned from Galileo. His first law of motion, that is Newton's first law of motion, is the law of inertia, dealing exactly with that concept of inertia, that objects don't want to change what they're doing. And what Isaac Newton said was objects at rest tend to remain at rest, and objects in motion tend to remain in motion unless they're acted upon by some outside force. That's kind of obvious as to us, but this all comes from the idea of mass, which is a measure of the amount of material present in an object. It is the quantity of matter in a body. It is not a measure of volume, so it's not a matter of how big something is. It's about how much matter is packed into it. And it is also kind of a measure of the inertia of an object, which is to say greater mass equals greater inertia. Less mass means less inertia. And the more mass an object has, the more force it takes to change its state of motion. You are probably familiar with this if you've ever had to push a car. It really takes a lot of force to get a large, massive car to start moving. It doesn't want to move. But once it starts moving, it kind of doesn't take a whole lot of force to keep it moving. But it does take a lot of force to stop it from moving once it is moving. So once it is moving, it wants to stay that way. And because the greater the mass, the greater the inertia. More mass means more inertia, and mass is always going to be measured in kilograms. Weight is the force due to gravity acting on a body. This is a very common mistake people make, is that they think mass and weight are the same thing. They are related, but they are not the same thing. In fact, they are related by this equation. Your weight is equal to the mass times the acceleration due to gravity. Now, since the acceleration due to gravity is different from place to place and planet to planet, your weight would be different on different planets. If you go to the moon, which we're going to consider a planet for the moment, if you go to the moon, you would weigh roughly 1/6 of what you do on Earth, because the acceleration due to gravity on the moon is roughly 1/6 of what it is on Earth. The unit of weight and the unit of all forces is the Newton. And 1 Newton is 1 kilogram times a meter per second squared. We'll explain that a little bit more in a few minutes. So on Earth, if you have a mass of 1 kilogram, you have a weight of 9.81 newtons. Newton's second law of motion kind of explains that a little bit. And what he said basically is that the acceleration of an object is directly proportional to the net external force acting on the object and inversely proportional to the object's mass. That's a big, long, huge, fancy way of saying that your force is equal to your mass times your acceleration, which is the mathematical expression of Newton's second law of motion. Basically, if I apply a force to an object, it will accelerate as long as I'm applying a force to that object, as long as I have a net external force. So as long as all the forces do not cancel out. If all the forces cancel out, then your acceleration is 0 because your net force is 0. But if you have a net external force, an object will accelerate. Newton's third law of motion is probably the most misunderstood and the most misused, but you've all heard it. And this is the long-winded Isaac Newton way of saying it. If two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and these two forces are in opposite directions. That is the big, long, drawn-out way of saying what we all know: for every action, there is an equal and opposite reaction. Now, I kind of oppose that terminology because that's not necessarily true, and what Newton was talking about was forces. So for every action force, there is an equal and opposite reaction force, which is to say that if I push down on the table with a force of 1 Newton, then the table will push up on my hand with the exact same force of 1 Newton, equal and opposite forces. That is called an action-reaction pair. I push down on the table pushes up on me. Action-reaction pair, Newton's third law. And that is it for now. We will discuss the mathematics of Newton's laws in a later lesson.